Welcome to homework.
So we have to find the pH of 0.07 molar of dimethylamine. So for dimethylamine. So for dimethylamine, we have this is a molecular formula of dimethylamine. But if we look at that, essentially it's just a base. So we can use a general uh, base ionization uh, reaction with water to calculate the pH. So what's going on is that if we have our base, it will gain one proton and then we'll generate our hydroxide ion. We're going to write our ice table. So we have a 0.07 molar, and then we don't care about water, and then we're 0 and 0, and then we're minus x being consumed and then being formed. So we're x, and 0.07 0 minus x. Okay, so the KB, you should be able to find that it should be equals to 6.9 times 10 to the left 4 from your textbook. And then you can write the KB expression will be equals to our the product of our concentration of our product, so x squared, divided by the concentration of our reactant. And this will equals to 6.9 times 10 to the left 4. Okay, so we just have to solve the quadratic equation for x, and then we should be able to find out the concentration of hydroxide. Okay, so when we are going to do cross multiply, and then we're going to arrange that in a quadratic formula form. So it's a pretty simple mathematics, so I just skip a step over here. So at the end, the quadratic formula you should look like that. So we have our Ka times x minus our Ka times our initial concentration. So you can simply do cross multiplication, and then you just rearrange that to have this quadratic formula form. Okay, we're going to use our calculator or quadratic equation to find x. And we should be able to find that x equals to 6.6 times 10 to the negative 3, or minus 7.3 times 10 to the negative 3. So for this case, we are looking for the positive answers because the negative answer doesn't make sense here because x cannot be negative concentration. Okay, so this is essentially equals to the concentration of hydronium over here, but we want to find out pH. So if you remember, pH plus pOH equals to 14. So therefore, pH can be found by using 14 minus pOH, and then we can find the pH. All right, so for pOH, we just simply take the negative log of our concentration of hydroxide, which will be our x. So we're going to take a negative log of 6.6 times 10 to the negative 3, and then we should have around 2.2. Okay, so we have 14 minus 2.2, and then we should be able to find that is equals to 11.8 for our pH.